Let's just see. If there's 3 comments, but I just want to see if they have a good answer. Oh. Oh. Doing integration by parts. Would that even work? Man, distributing everything out on this feels bad. Is this... I want to look at the graph of this. That could be important. This might be one of those ones you can play around with the bounds or realize that it's odd or something. It's an, it is an odd degree function. It's a 17th degree polynomial, dude. What the hell? X squared. This feels like one of those competition math problems where there's a some kind of weird trick. Plus 3x plus 2. Oh, really? To the 5. Okay, well, playing with the bounds isn't gonna help. Dude, that is... we haven't even gotten to like, the line for 1 is right here. And just look how fast this function is shooting up, dude. We haven't gotten to x equals like 0.5 yet. We're about to. It's crazy. Okay, so no, I don't think the graph is going to be particularly helpful. I assume that if I gave this to Wolfram Alpha, it would just multiply everything out. Let's just see, though. Is it that? Look how ugly that is. Yeah, they expanded it out. We can try one last thing, which is giving it just that polynomial and seeing if it finds some kind of nice reformatting. Wow, that's quite the real root right there. Holy crap. Okay, no. I don't think we're, it doesn't seem like there's a shortcut. Bob? Nothing much. How about you? So if you did integrate by parts and you derived the right part, you would end up with the integral of 1/3 x cubed times 3x squared plus 3 times... Ooh, I don't think that's even... Oh my god. Almost no sleep, but you're awake AF. Oh. Well, save it for Friday. Oh, shoot. What? Thank you so much, Bob. Why didn't the alert play? Oh, don't do this to me, Stream Elements. But hey, thank you so much for the sub, Bob. And oh, did you not mean to? I'm sorry if you didn't mean to. You're gonna... Okay, it's definitely not an obligation, so, you know, if you ever cancel it, I genuinely do not care, but thank you very much. And let me... I'm putting up my stream elements right now, because this is... The alerts were working again, and now I guess they're broken? Like, what the hell? Let me send a test alert. Oh, shoot, it's playing... Okay, so that worked. When I played a test alert, it just hates Bob. Okay, there we go. Okay, there. I got it to play eventually. I don't know why Stream Elements is asleep right now. Like 1 hour nap in the afternoon, noise your way. Oh my god, Bob. That sucks. Yeah, I mean, please don't feel obligated to go on Friday then. Your sleep is way more important. Hope you're able to catch some sleep soon, man. All right, this one has made me curious. I want to see what happens if you try to integrate this by parts, because it's a good thought. This is definitely integration by parts. I'm not so sure about that. I feel like it doesn't necessarily... I mean, if it's being given to a calculus student, I would think it has to be. But when I try to work it out in my head, it didn't seem like it cleaned up as well as they might think. So let's just... I kind of want to investigate this. To the 5th dx. Okay, so if we integrate that by parts, we would take u equals x squared and dv equals... No. Other way. We want to derive this monstrosity because integrating is even worse. Our dv is going to be x squared dx. We derive our u, so we get du equals 5 x cubed plus 3x plus 2 to the 4th times 3x squared plus 3 dx. Good. Our v, when we integrate it, becomes 1/3 x cubed dx. Not dx, just regular. Okay, then we do uv minus v du. 1/3 x cubed plus 3x plus 2 to the 5th minus 1/3 x cubed. I'm going to change that to 5 because we have the 5 there. 3x squared plus 3, x cubed plus 3x plus 2 to the 4th dx. Now with this, I guess we do a u sub with u equals... not 3x cubed. I think what they're saying, the people are saying integration by parts, is that you do u equals x cubed plus 3x plus 2. Du is 3x plus 3 dx, 3x squared. So that cancels with that, but we still have the x cubed there. So I don't know. Like, that doesn't help you, I don't think. No, Bob, because if u equals x cubed plus 3x plus 2, then du is 3x squared plus 3. It's that plus 3 that messes it up. That's what I thought too, like just off the bat you do a u sub with that, but the 3x derives to 3. Yeah. So I just don't think there's a clean way to do this. Besides multiplying it out, which really sucks. I mean, you could integrate that by parts again, in theory. I don't know. Wait, would you integrate that by parts again? Would you integrate this and derive that? That seems horrible, though. No, I'm not going to do that. Okay, that's just a horrible problem, I think. Like, it takes a ton of work. So I don't know, do I want to, like, say that I tried to enrich my parts and it didn't seem to really help? By parts. But if that's true, it's probably going to be about as much work as just multiplying the thing out. Put into Wolfram? Yeah, Wolfram just does it the Chad way of multiplying it out. And honestly, like, it's such a stupid problem that I wouldn't blame the student for just Wolframing it. There's a, what's called, the integral calculator. Another damn likes a slut. Let's see if this gets a different, or if this uses a different technique. X squared. X cubed plus 3x plus 2 to the 5th. Oh my god. Wait, what the heck is this? They say that x squared is equal to 1/3 3x squared plus 3 minus 1, which is true. And they take... And so this term on the left is from this part. This term on the right is from the minus 1. Apply linearity. I guess it just means bring the 3 inside there. Oh, and split the integral up into 2. This... That's not a valid U sub. You don't get that cancellation. Wait, yes you do. I'm dumb. Okay, so yeah, you do get that cancellation. But you still can't get around that. All right, I think this is worth mentioning though. with integrating third x cubed plus 3, x cubed plus 3x plus 2 to the fifth plus x cubed plus 3x plus 2 to the fifth the first term just a u sub, but you still have to integrate the second term by expanding it out first. Only saves a bit of work. Actually, it doesn't really save work at all. I mean, doesn't really save any work. I think I'm still mentioning this because there is a trick to this problem. It's not really a helpful trick in this situation. But this is such poor phrasing. It doesn't seem there's an easy way. Oh, I did the wrong thing. There. It should be squared. And that should be 3x. And that should be a minus. There. Copied it round dong. Copied it round dong. Down wrong. There too. Okay. It's an interesting problem. Senior school math? Wait. I've heard of senior school before. Is that for old people, or do they mean like high school senior? Either way, I'm in. Got a 2-variable optimization? Maybe they mean university senior. I'm gonna put my mug away though, quick. Okay. Okay. Each unit of good. I'm a unit of bad. The Lagrange multiplier method. Yeah, this is definitely not high school stuff, unless they're some kind of genius. I've done this before, but I need to see it. Mm. Sorry, I'm just like trying to understand this still. Maybe we should just dive right into it, though, you know? Fortune favors the bold. So, okay, so they get this system of equations. Okay, that seems a little messy, but okay. Let's see if we can work this one out. I guess the site did warn me that the process, or like the idea is simple, but the execution is not always. So we have u of x1 comma x2 is equal to x1 x2 squared. So the consumer has a total amount of 100 to spend on the two goods. So utility function, I guess that's how much the consumer needs, and they need x2 squared as many times as we need x1 good. That's not particularly meaningful to me, but I guess x2 is more important than the x1, but they still need both. So, but I guess the important takeaway is that x1 costs $1 each, x2 costs $2 each. So we know they have $100 spent in total. It should be x1 plus 2x2 is equal to 100. Is our constraint. 3. Oh, I was getting the names mixed up. Scorpra, 3-stream watch streak. Thank you. Got that height. Okay, and so now we need to take the gradient of each of these. I'm gonna call this G to match Paul's online notes. So let's say gradient U is equal to partial in terms of x1 is x2 squared. Partial in terms of x2 is 2x1 x2. And then we need lambda times gradient of G, which is lambda times wait. That doesn't feel right. How do we take the gradient of that when it's equal to a constant? How's it going today, Scorpra? Okay, so our constraint is this. Going well so far? That's good to hear. So we just ignore the constant for this. Okay. And the constraint comes in at the very end for our fourth equation. So are we just gonna have a simple case here? Because the gradient is gonna be 1, 2. Which I guess that saves us work, so I shouldn't complain. Okay. Well, the partial in terms of x1 for just this chunk is 1. Partial in terms of x2 is 2. That's fine. So from this, we can get 3 equations. We'll have 3 unknowns. We have x2 squared is equal to lambda, because we equate the x's with the x's. Then we have 2x1 x2 is equal to 2 lambda. And we have x1 plus 2x2 is equal to 100. Okay. I guess we're gonna divide that one by 2. And don't we get that x2 equals x1 here? Hey, Jeff. Does it make sense for x2 to be 0? I don't think so. We're certainly going to need a lot more of x2. So in theory, could not buy any of x1 or x2, but surely to maximize the utility, we're going to buy a lot more of x2. So I don't think we need to worry about x2 equals 0 in this context. So if we equate that with that, because they're both equal to lambda, we get x2 squared is equal to x1, x2, and we can divide by x2. I mean, we could even be even more careful and subtract it over equals 0. Factor out the x2. And then from here, we have either x2 equals 0, which I don't think is going to make sense, or x2 equals x1. Oh shoot, my cam is still on. Ugh, the small cam. So yeah, we're switching back and forth constantly. Really? They're gonna equal each other? Well, here, actually, maybe we should examine this case. So if x2 is 0, then x1 is 100. That's not 100. It's 0. Okay, and then if x2 equals x1, so like 33 and a third. X1 equals x2 equals 100 over 3. That's weird that we don't get more solutions. I feel like it shouldn't be something like that. Um, this is kind of weird. I'm going to be honest. Given how similar different procedural programming languages are, how do you propose writing a mathematical function in such a way that can be easily computed by any language, so it be rewritten for each language? Yeah, it's a Lagrange multiplier one. I feel like my answers don't really make sense, though. I mean, I don't really know how you would write something to be universal for languages. Wouldn't you always need a library to make the language work? Unless you just mean like, I guess if you just mean easily computed, like wouldn't that just be power series or something? It depends on how you do the power series, but as far as I know, like if you give a computer sign of 1, they use power series. Depends on your application, I guess. Does the actual value of lambda matter? Actually, did I multiply lambda by the right thing? Okay, yeah, you... Multiple variable functions. What about the radius of convergence? It's true. It's kind of like a huge question that I haven't even researched slightly, so I'm not sure. Astro just put a question. Thank you so much for the sub, Astro, the 5 months. I'm not sure exactly how you do that one. Is that a meme? It's not actually possible. It's not. I don't think I've solved this one. Given it's a square. I might have an idea. Let me just, since you did say for after the one that I'm working on now, let me see if I can. If I can figure this one that I was working on out. Yeah, Jeff. So I think you can do something from the center to like halfway through the square, and it should be the same distance as from halfway through the square to the center. You can figure something out from there. Hey, Mangoes. Yeah, I'm trying to do a Lagrange multiplier one, but my answers don't really make sense to me, so I was seeing if I could figure it out. I don't know, dude. This is the original problem. It's that it seems like you should buy more of X2 than you do of X1. But I guess it does cost twice as much. I'm getting that you buy the same amount of each. No worries, Mangoes. Yeah, no, I love the site. Thanks for lurking. No, X2 costs twice as much. So it's 33 and a third of each. 25 and 75. You're overspending though. It's a third and 2/3. It's what I've gotten. Or it's a third and a third, but it comes out to be a third and 2/3 because of X2 costing twice as much. (100/3) is X1 times 100. I mean, I guess that's a... That's 37,000 utilities. Okay, that's a lot of utilities right there. 37 kilo utilities if you're a person of science. I guess it's that. It's certainly not x2 equals 0. I don't know. I guess it makes sense. I guess you still have to verify. Actually, what is it? I can just graph this in Desmos. I just want to see what the function looks like, and then I'll get to Astros. Z equals xy squared is basically, ooh. And I'm getting something like somewhere around here. corner conditions. I most certainly did not. But x1, x2 squared, I don't think it has any like a discontinuity or something like that. They should both be greater than 0. I think it's 100/3 and I'm overthinking it. You know, I'm just gonna look at this one that Astro posted while I like kind of sit on that Lagrange multiplier one. The idea of senior school math is kind of funny to me still as well. Just a bunch of old people doing math. So for this one, my only idea is extending the radius to the bottom middle of the square. Or, I mean, you don't remember the answer, so you just take my word? Okay. I like that. You know, I wish the world worked like that, Astro. Just whatever I got, it's right. Who cares? So if I come over here and I say, remember the process though? Okay. How do I want to draw these? I'm gonna say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm gonna make that the center of my first circle. And I don't care about the rest of it. That's really the most important part there, that like lower right part. 1, 2, 3, 4, 5. This is gonna look dirty. Okay. I'm not drawing the centers. How about that? It still looks like a butt though. Okay, you know, sometimes you gotta do what you gotta do. You asked for math. I know, Asher. I'm sorry if I'm getting you all hot and bothered here. It'll look a bit less like a butt and or boobs if I draw that. Okay. So that's what we're given. My idea, sorry, I should be right. 0, 5 for that center. 10, 5 for that center. My idea was to go from the center, extend it through the corner of the box, and I assumed down into the middle of the square, but I drew it badly. Hey, Jed, you got this? Okay. And then if you can get the, well, we don't necessarily know how to make that line though, do we? I would think these lines should be perpendicular. I mean, maybe, I don't, that's probably a leap. Oh, okay. Thanks for looking at that, Jeff. The common internal tangent? Oh, between the two? Like going straight down? If this is a butt, then this tangent is the poop, I guess. If I put it in like little kid terms. Like potty humor. Oh, you could do this with calculus, right? Because we know the equations for each of these circles. You just find where the tangent is undefined. Well, actually, well then how does that help you though? I can already name that point. It's 5 comma 5, and it goes straight down. That does bisect the square. But we don't know the width or the height still. Consider the square of size 5 meters formed by the two radii in that tangent. The two radii in that tangent? Where do you get a square? Or you get two separate squares, right? Like you get a square here and a square there? The two radii of the left circle. Okay. Consider one of them. Okay. Yo, Zach! Thank you so much for the raid. Beef Juice, Foodib, hey. Peach Tea, hey. Thanks, Jed, for shouting out Zach. Yeah, if you don't know Marty Zach or eats the two-eyed pie, check him out. He's awesome. Thanks so much, and welcome in, everyone. I was like actually watching your stream at the start, and then I had to lurk for a bit, but I hope it went well. Anders, hey. Okay, so we're just working on this for it's more of a for fun problem from Astro, and actually in a different way I was kind of considering Jed's idea already, because I was already I'm following along the train of thought that Jed was putting in chat, which is we can form a square if we draw a vertical tangent line going down, and then we have a square like kind of inside here with the tangent, the axes, and the radius. And then Jed's saying to consider the diagonal of that square, which I'm going to happen to draw. Oh yeah, and on the right here, I was working on a Lagrange multiplier one. This work over here is completely separate. I just got stuck for a bit on it, so I was letting it marinate. But I think I got to the right answer here. It was like a consumer spending like optimization problem. Don't know if that helps or not. Oh, so okay, that's as far as you've gotten, Jed. I don't know if that helps or not either. It gives us an upper bound. Consider 9 plus 6. 27, obviously. Huh. So Asher, if you are still here, is this like the right track? Or is this, are we on the completely like wrong tangent? So I guess all we've done so far is draw some diagonals, but I don't know if we even need these. I could definitely see a calculus way to do this, but I feel like there's supposed to be a geometry way. No, kinda? Huh. Are we on the right tangent? Oh, I didn't even think about that. Oh, I wish I did that intentionally. Not best puns on Twitch. Could we figure out? Okay. I don't know how many times I need to say okay, but if we drew this diagonal of the square, these diagonals are equal to each other, and we know the length of this diagonal, so we can get the length of that diagonal, taking them as equal, and that's root 50, which is 5 root 2. And so the length of this in the square is 5 root 2 minus 5. So could we boil this down to 5 root 2 minus 5? Those are equal. These two are equal. Those angles are equal. I'm making a couple of leaps here, but I feel like this is right. Like, could we accurately say it's like this problem now? And just try and get the side length of the square? You draw a second radius line straight down. You top line of the square to meet the new radius line. They can use Pythagorean. I was trying to use different colors to show that they're not equal, because I don't want to do like a million tick marks, but... Okay, let me see what Astro's saying. So that seems like it's probably an easier way. Like you basically make a rectangle with the radii, it seems like. My drawing is definitely not perfect, so I feel like I'm making a leap here. So you just extend the top line of the square. So like, oh, like you extend this top line of the square. Okay, let me try this in blue. Like you extend it like that? Okay. And then you draw the radius down to meet it? So you get a right triangle there? You drew this to scale and GeoGebra and got an interesting answer? I already had that on the left? Oh, okay. And so we know that the... Oh, okay. Oh! I see where this is going now. So we know the hypotenuse is the radius, which is 5. Wait. I had it for a second. Do we... Oh, we don't know what the bottom is, though. I thought we knew what the bottom was. What? How do we Pythagorean theorem, then? I don't think we know what the side is. Wait, we do know what the... Am I stupid? The answer is probably yes. How do we know what that is? we make the length of a side of a square x. Let's clean up some of my work here. Yeah, Jeff, I think we want a geometric solution. There's definitely a calculus way to do this too, but this has geometry vibes to me more. Make the length of the square x, then that means the height is 5 minus x of that part. And then you Pythagorean theorem for the bottom. Oh. Okay, so that's a good step. Okay, so let's put the Pythagorean theorem. And sorry, Jeff, if there's a different... I assume that the only other way is calculus, but if you see another way, then that's interesting too. 25 is equal to 5 minus x squared. I mean, so can we call that anything besides like b or something random? I guess we just call it b, or I don't know. Also, I don't know the Pythagorean theorem, evidently. Remember what that one is called? Finish drawing the right circle? I definitely don't see where we go from the Pythagorean theorem there. Oh wait, could we also say that it's... Well, is that also 5 minus x? Is it inequilateral? Because the square is x. From here, I think we can figure it out, because we know it's a square. It should be x divided by 2 for just half the square, and 5 minus that. I think it's the length of the bottom. 5 minus x over 2. I think it has to be like that. So it's not, it's probably 30, 60, 90 or something. I don't know though. Let's see what we get for our x there. Because I think that's how you do it. Here, let me follow this through, Jed, and then we'll look at yours more. This seems pretty promising to me right now. Okay. 0 equals 5 over 4 x squared minus 15x plus 25. I'm not cutting myself off yet? Okay. You still exploring yours? Okay. Let's multiply the entire thing through by 4 over 5. Yeah, okay. That factors to 10 and 2. X minus 10, x minus 2. So x equals 2 or 10. 10 is surely too big, so it must be 2. Is the answer 2? Oh wait, you said you don't remember the answer. Hell yeah. Oh, wait. Oh, the area of the square. You're right, Jed. 4. That's interesting. They can just do it like that. Try drawing it on. I don't know how to work GeoGebra still. I haven't really played around with it much. I mean, you know what? You probably coach me on it, though. Let me open up GeoGebra. GeoGebra. Then after this, I'll write a reply to the Lagrange Multiplier person, who's apparently in senior school, whatever that means. Wait, calculator. That's not what I want. That's not geometric. Come on. Dude, stop. Let me go to the homepage. Oh, it brought me over here, that's why. Oh. Geometry, that seems promising. You would think that geometry would be the first one that they show. Calculator works fine, really? Open up both, because it's going to take a million years for it to load. Oh, okay, it does work. Okay. Tools. Draw the bear that's on my flag. Okay. Circle with center. Oh. Go away. Go away. Start at 5, 5. There. Wait. Oh, I lost the circle tool. Okay. 5, 5. Circle. Okay. No, stop it. Too many circles. Can I just hit delete? Okay, good. And then you have to just look at the gap that's left. Oh, yeah, you can literally just look at it like that. GeoGebra did better circles? What? I thought mine were perfect. Okay, that wasn't too bad to draw. Okay. It's cheating. Yeah. Sue me. That was cheating. That's cool. Kind of like, how hard is it to get the area, like... Okay, fine. I'm okay. Cheating with asking ChatGPT. Well, that cheating with ChatGPT is like asking the worst performing student in the class what the answer is. Like, you're not gonna get a good answer. Okay, so let's get Astro's bear in, and then I'm gonna work out this Lagrange multiplier question, how to reply to it. God, that's a perfect circle right there, I gotta say. You're in a rush? No, you need your bear. It's life or death. Okay. Oh god, that's gonna be so annoying. Um, okay, let's start with the back. The back is probably the easiest. Draw that booty. Well, he's got some thick thighs, this bear. Okay. Bam. We're getting there. We're gonna need to draw some claws and stuff like that. The bear butt? Yeah. Okay. We got the body. We need the head. Got some teeths. You know, that's not as bad as I thought it'd be so far. I probably shouldn't speak too soon. This is only the outline too. We're gonna fill it in. It's got a little chin. Okay. You know, the ear's looking a little weird, but, you know, just trying to make fun of the bear for it. Okay. Need some claws. Big, meaty claws. Oh wait, we need its other ear over here too. Okay. Get like the shoulder blade in there. You mean it's not bad? There it is, yeah. Cerberus? Kind of. He's missing a head. And it's at least supposed to be a bear. Actually, his ear is looking a little... His ear's looking a little droopy there. When I look at it from a bit further away. That's... it's a little far away. This is a special bear. Okay. Better-ish? I don't know. I can even try to do the shading. Let's see how that goes. So, you know, I don't just want to leave it at that. I gotta make this a masterpiece. Yeah, I think this is making it worse, I'm gonna be honest. Okay, well, I tried. Okay. I hope that satisfies your every dream, Astro. Okay. Minnesota has selected a new flag? I have not heard that. It's a, you know what? It's about the best compliment I can hope for, Astro, so I'll take it. Wait. Oh, I did it! Minnesota, there, oh my god. Flag. Oh. That doesn't feel like a state flag. I feel like you don't normally see like blue like that. Does that have a certain meaning? 8-point North Star. What was the old flag? Flag design experts. In one of the worst designed flags in the state to the top 10. Okay. That's interesting. I didn't know that they got a new flag. Doesn't look bad. I want to see old flag. Oh, wow, that has like a million different parts to it, doesn't it? Huh. Okay. Can see why they changed it, I guess. All right, back to this Lagrange multiplier. Vexillology? I feel like I've heard that term. I don't remember what it means, though. Because this is the problem that I was initially working on. Two-variable optimization with a constraint, so we use a Lagrange multiplier. So technically, we should verify that it is indeed a maximum. I'm like 99% sure that it will be, and Jeff verified it with like making it into a one variable. Dr. Sheldon Cooper's fun with flags. Oh, vexillology is like the study of flags. But I definitely have not watched The Big Bang Theory. If that's, isn't that Dr. Sheldon Cooper? I just know there's a character called Sheldon, I guess. That's what made me think of that. Okay, and then what? Can you prove that the function itself without respect to g is a maximum, or what? Okay, it is Big Bang Theory. Oh no, you just plug all the solutions in and see what the actual value is. And so we did do that. In gradient g is not equal to 0. Gradient g is never equal to 0 here, though. Because it's constant 1 and 2. Okay, I think I feel calm enough to reply to this one. You didn't help me with this one. So they didn't post their attempt, or were they exactly confused? Wait, isn't the g in Lagrange supposed to be capitalized? Evidently not. Okay. Lagrange, Illinois. Okay. Math. No, okay. I assume G was capitalized, I guess not. Isn't Laplace? Okay, I'm sorry, I'm going off another Laplace math. That's it's not capitalized. Okay, I don't know where I got that from then. Lagrange multiplier method. Take U is the function we wish to optimize, and our equation for the constraint is for the constraint, which I'll just call G, is G of x1, x2 equals x1 plus 2x2 equals 100. This comes from the cost of x1, just 1, or $1, times the amount of x1, and the cost of x2, $2, times the amount of x2, must add to the consumer's total available money. Money. $100. From here, you set del u equal to lambda del g equation. I think I'm going to give them that much. If they don't know Lagrange multiplier, then this is kind of all a waste to say, but I assume that if they're doing a problem like this, they have to know Lagrange multiplier. So let's post that. Okay. Oh, I do want to look at this one again. There's a lot of new comments. Someone was given this integral, was asking if there was a trick. And there wasn't a trick that was really helpful. They ended up just distributing everything. And they were off because, you know, of course they made an algebra mistake. It's kind of impossible not to, I feel like. Yeah. That is a good call. I was wondering about the binomial theorem, but it wouldn't apply to, of course, something with 3 terms. It would let you algorithmically get each term. It would still be a ton of work, but you're way less likely to make a mistake, I think. Okay.